Cool. This will be good. So I think audio is a little bit difficult for me. I can't really hear people who are in the room in Alder 103 when you're talking. So what I'm going to ask you to do that is that if you have questions, type them into the Slack channel, and I'll pause often to sort of see what questions people have as we go along. But at any point, if questions come up, feel free to type them into the Slack channel, and we'll try to address them. I have Slack right in front of me here, so I'll see when you post any questions. Let me get started here. So, okay, the goal of this session is to teach you about Git and GitHub, and to introduce you to some slightly more advanced collaboration patterns that use Git and GitHub. Git, I assume folks here have seen Git before. That's kind of like the premise of this, is that maybe you've seen Git, maybe you've used it before, and you're ready for slightly more advanced usage patterns that we use in the wild, or in large projects, in large collaborative projects. And so that's what we'll introduce here. So what I'll do is I'll start with kind of like from scratch, but I'll go really quickly first just to kind of reintroduce you to Git, maybe mention a few things that you haven't heard before, or just it's good to get a good conceptual framework of Git when you work with it. Like, what is it doing? What are the different parts? I think a lot of us use Git, and we remember some commands that we type in the command line, and then if things go wrong, it's very hard without having slightly more of a conceptual framework for what are the different parts and what are they doing and how they're interacting. So we're gonna try to, along the way, a little bit give you a conceptual framework to think about Git and GitHub as well. Okay, so first of all, what is Git and what is GitHub? Those are two different things. Git is a source code management system, SCM, or a version control system. Sometimes people call this version control. Sometimes people will call it revision control system. The idea is that this is a system that looks at a part of your file system and keeps track of files that are there and changes to those files. And Git is a very sophisticated version control system that allows you to do a lot of complex operations with the different versions that you have, including things like creating new branches that allow you to switch back and forth between different versions of your file system. It allows you to then collaborate with people using really complicated collaboration patterns. So that's Git. Git is an application that's installed on the machine that you're working on. Meanwhile, GitHub is a website that allows for additional collaborative patterns that uses Git in order to facilitate various kinds of collaboration patterns between individuals who are working together on code. And these can be individuals that are close collaborators who know each other. But one of the nice things about GitHub is that it enables also collaboration between people that don't know each other on large projects where many people go into this kind of public space to work together on open source software. And then they can make contributions. People can come to public open source software projects and make their own contributions using GitHub in a way that's facilitated by the website. And hopefully by the end of this session, you'll see how that works. Okay, so let's start with Git itself. Who here? Here I'm gonna type a question in the. So we'll go and start using Slack. So use thumbs up to say yes and thumbs down to say no to the question that I asked. The question is, who was here for yesterday's session about Python libraries? And the reason that I'm asking that is that I'm going to use the Python library that we created yesterday in yesterday's session as the thing that we will do version control on. If you weren't here, that's fine. But if you were here, and it looks like everyone is here pretty much so far. Everyone who's answered so far was here yesterday. Okay, good. That's good also because I can then tell you what went wrong yesterday. So if you were here yesterday, you remember that things went wrong, and that was because of a misorganization on my part. So if you remember yesterday, I organized the code in a way where there was a directory called geometry, and under that there was another directory called geometry, but actually there should have been a directory called src, and under that there should have been my package. So I created one more layer here. And once I do that, then I can actually go and install that. So let me cd into that location. I had it under source geometry. So here I am sitting right here, and I can do pip install, Python dash and pip install dot, and then it goes and it installs the library, and I believe it installs its dependencies also. And once it's done doing that, if you remember, I had this attempt yesterday to go and create a notebook somewhere else and import from here. I believe this should work now. So this works now, and we have geometry dot circle dot calculate. Okay. So that's how this is now fixed, and we'll use this as our example for so right now, if I type git status in here, and git status is something that I will type a lot, it will tell me this is not a Git repository, and you need to do something about that. So let's say that I have some piece of code that I am versioning, that I'm doing version control on. The first thing that I need to do is I need to initialize a repository where I will be doing my work. So again, I'm inside of home Jovian, that's the username, that's kind of my home directory. Then I create a directory called source where I'm going to be doing all my work. And inside of that, I have a directory called geometry. And inside of that directory is where I will type git init. And it will complain because it doesn't like my use of master. So I'm going to change git branch dash n dash m main. And this is a one-time operation. One of the things that we will do first, that you will also do on your machine, is to configure Git to recognize that you are the user of Git in this case. And I'll show you how to do that in just a second here. This is an operation. These are operations that we need to do only once on every machine that we work on. Here I'm going to follow Git. Sometimes when you try to do things, it will give you some advice or hints about what to do. Here it's hinting that I'm using master as the name for the initial branch, and maybe I want to change my configuration. Global init default branch. And one very common convention for this is to call them the default branch name for Git, call it main instead of calling it branch. So I'm going to do that. And then I'm going to follow the second hint and modify the name to main. So now if I type git status, it will tell us that we are on a branch called main. And I'll tell you more about branches in a little bit. There are no commits yet, and there are some untracked files in here inside of this folder. Now, when working with Git, the first command that you type is git init, and that initializes the repository. Again, that's a one-time step that you do only once in each repository. Another step that you want to do, and maybe in this case, go into the Jupyter Hub and follow along with me as well, because later on we'll do a little bit of hands-on stuff, is git config dash dash global user name. And here I'm typing my name. This is again a something you need to do once on every machine that you're working on. So go ahead and do that on your machine here or in your Jupyter Hub. And the other thing you need to configure dash dash global is also your email address. And I will use the email address that I use in GitHub, which is my Gmail address. So let me just copy that in case folks want to have that in there. Copy that into Slack. So you have that in front of you in Slack when things go off. Okay, so these are configurations. We need to tell Git who we are because it's going to attach that to all of our commits when we make commits. So before we can make any commits, we need to configure that stuff. We'll do some more configuration later on, but let me do some Git first. After you initialize the repository, the next command that you will use is git add. Git add allows you to add files into the repository. For example, I can point to the README file in this repository, and I can add that. Now I'll type git status again, and git status tells you a little bit about what's going on. The difference, note the difference from here. Here it says there's a bunch of untracked files, and it's actually giving us the hint, git add file, to include files in what will be committed. Now it has a new file in what's called the staging area. This is the staging area for Git. Git has followed this model that when you add files into the repository, they get staged for a commit, and only then do they get committed. Oh, let's do one more configuration step here before we move on. Git config dash dash global core.editor nano. So this is one more thing. Git will use our a text editor to do different things. You'll see how that what that looks like here in just a second. And the text editor that I recommend using for that, unless you're very comfortable with Vim, I recommend using Nano, which is a very simple text editor. So I'm configuring Git to use Nano. And the reason that becomes important is that I'm now going to do git commit. So now everything that is in the staging area is going to get added to a new commit in this repository. Adds project. Wow. You notice that when I did git commit, it automatically opened this text editor. And I can go and I can edit this text editor. What I'm editing right now is the commit message that will go along with the commit that I just wrote. Commit messages are important because they give you, later on, you'll have a log of the project history, and each commit will be associated with the commit message. And that's something that you might want to look at later, or other people working on this will want to look at later in order to know when did different changes happen. This is a little note that you're giving, a little message that you're giving yourself 6 months from now, or somebody else who will look at the code and subsequent. And now we're inside of Nano. Nano is helpful because it has this little help down here that tells us how to do things. Write out, Control O is saving the file. So you need to save the message. And it writes, oh, I'll write that into this commit message, commit edit message file. And I type enter and then Control X to exit. And then it made this commit. Now if I type git log, it will show me the log of the history of this. This has a very short history so far. It's yeah, that's a good question. I haven't actually given you these files yet to work with. I'll give them to you in just a minute. Okay, let me finish doing one cycle of changes here, and then I'll push it to GitHub, and then we will pull from GitHub. and then you'll have the files, okay? So for now, just look at this, and we will do more of this, a lot more of this, so you'll have hands-on the ability to do this on your own. Okay. Okay. So now I'm going to add other files here as well. I'm going to add the Pi project file. I'm going to add the source. Oh, source. What's in the source? Oh, there's geometry. And within geometry, I'm going to add init. So now I've added several files in here, and I have several files here. And I am going to git commit that adds Pi project. Oops. And I saved that. I now can look at the git status situation. And I'll deal with these files in just a second. Let me just add the license file so we have everything complete. You'll see there are these other files here that I don't want to use, but we'll get to those in just a second. I want you all to have the code in your hands first. So git status, git commit. Okay, so now I still have these files that I need to deal with, but I'm going to first go to GitHub. And we're going to start working on GitHub straight away. So just to recap what we've done so far, we had some code on our machine. We initialized the repository. We added the files that are in that repository or a few of the files into the repository, and we made a couple of commits. So now our history is, we first added the README file, we then added the Pi project config and source code, and then we added the license file. So we have these three commits in our repository, and you'll notice that they are organized chronologically with the most recent at the top. You'll see that as we add, things will get added. The next thing that I want to do is that I want to start a repository in GitHub. And in order to start a repository, I can go to this create new. So you won't be doing that yet, but we'll do a little practice later, and you'll create your own repositories later. But for now, I'm just going to create a new repository here. When I click create new repository, it gives this interface that allows me to, I have many organizations that I'm part of, but typically I'll use my own username, and then I will start a repository called geometry here. And for now, I'm not adding anything. It allows me to choose the visibility. I can make this public or private, but I'm going to make this one public. It allows me to choose some kind of template to initialize this with some starter code. It lets me choose if I want to add a README or not, and git ignore a license and so on. It can even let you enter some text for an LLM, in this case, Copilot, that will go and create whatever you tell it to do here. But we're just going to create an empty repository. So one thing that GitHub lets you do is create an empty repository. This empty repository will contain all the content that we have on our repository on our machine. We're going to push things from our machine to this repository. And then we're going to pull things down from this repository onto our machine as well. So here it describes, you have this empty repository right now. It's public, it's called geometry. And it says you have two options. If you have an existing repository, you can follow the following instructions, which entail adding a remote and then changing the name of the branch to main, which we already did, and then pushing the repository to the remote. So we're going to follow those instructions. We're going to start by designating a remote. A remote is some other computer that this computer, so the computer that holds the Jupyter Hub, where our repository, our files are currently sitting, it can communicate with other computers. In this case, it's communicating with this other computer, with GitHub's servers. So I'm telling it, I want a remote called Origin. I want you to add that to this repository. Before I do that here, I'm going to put this hash sign so this doesn't get executed. I'm just going to tell you that if I type git remote before I do that, it doesn't show me anything. Now I'm going to do git remote add origin git at github.com /arokem /geometry.git. And when I do that and I type git remote, it will tell me, oh, you have a remote called origin. And if I do git remote -v, -v, it will tell me the origin is this machine. That remote is this machine, the GitHub machine. Okay. So now I've told Git locally that there's another machine that we're going to talk to. It's this machine called GitHub. And the next thing that I can do is I can do git push origin main. So I'm taking the main branch, the branch that I've been working on, and I'm pushing it into GitHub. And it does some things, and then it will have pushed it so that now, when I refresh this page, it now has my code in it. And the history contains the 3 commits that I made so far. So this repository is now holding my code in it. It has my code. And it has all the history of the things that I did over the last few minutes. Okay, let me pause here for just a second and see what questions do people have so far. Okay, if no questions, I'll keep going here a little bit more, and hopefully you'll get your hands into some more code in just a second, because you're going to pull my code. But before we do that, another few steps of configuration that we need to do. So in order to be able to talk to a remote computer, Git needs to have it has to have some way to authenticate against this other computer. So this is like how when you log into some computer, you do SSH on some machine, you authenticate using, for example, a password. And you can authenticate with the password against GitHub, but the more common, by far more common and much more useful way of doing that is by configuring what are called SSH keys in your machine. So we're going to go into in the Jupyter Hub, go to the docs git setup page, and we will, so we've already done this, tell Git your name and email address. That was this git config global -- global username, Ariel, Rokem, What we need to do next is to create an SSH key for authentication on the Jupyter Hub and providing GitHub with this key. And there's steps, these steps are explained here in detail, but I'm actually going to ask you to go to this page instead. GitHub SSH keys. First, this page here, which will explain how to create an SSH key locally. and follow these instructions. So it's really this command here that creates an SSH key. Except replacing your email at example.com with your email address. It will ask you a few questions. It'll ask where to put this. And you should follow the default configuration, right? You'll see here it says enter a file to save the key, users u.ssh, and so on. And you should let it do the default thing, which will save it into a .ssh folder in the home directory on the hub. And then it'll ask you for passphrases. And I typically actually, for this kind of use case, I don't set any passphrase. So if you just hit the enter key here twice, then this won't be password, the SSH key itself won't be password protected. And that's fine for this kind of use. So go ahead and do that. Let's see, maybe give me a thumbs up in the Slack channel when you're done doing that. And then after you're done with that step, we will need to do the second step, which is to add the SSH key to your GitHub account. So then you follow the instructions that are here. Once you have an SSH key, you can follow these instructions to add the SSH key into your GitHub account. It essentially what it will want you to do is, well, let's start with the first step first. Give me a thumbs up on give me a thumbs up on step 1 when you're done with step 1, and then we'll go to step 2. And feel free to type questions if things come up in the Slack channel and draft added. You actually don't need to do the SSH engine thing. There's in this thing, there's this whole thing about this SSH agent. I don't think this matters much. Okay, I see 4 thumbs ups for the first step. Let me know if you're running into any trouble there. And I think there are about 8 people here, so I should have 8 thumbs up eventually. Oh, and someone's even done step 2 as well. Good job. All right, I'll go to step 2. I see most of you have done that. Step 2, just to give you a hint of where to go, it gets a little confusing. If you go to github.com and you go to your username up here, if you're logged in, you'll have this user navigation menu, and you go to settings and you go to SSH and GPG keys here, then it should open. I'm wondering if I should open this because it might contain some private information that I don't want to show. So I'm going to take that off screen for a second before I go and do that. Yeah, I think it contains some information that I don't necessarily want to show the world, and this is going to be on YouTube, so I'm not going to put it back on screen. But if you go there, you can click on new SSH key, there's a big green button called a new SSH key. And then as the title, you might write something like NeuroHackademy Jupyter Hub. This will be like the way that you name this key so that you know that that's the key. And then the thing that you will paste inside of the key field, this big field, big gray field under that called the key field, is the output of this pb copy command. You can also do if you're in the terminal, you can do cat dot ssh slash ed id dot pub. If you do that, that's your public key. So if you do that, I won't do that here because again, I don't want this on YouTube. But if you do that, it'll show you a string of letters and numbers down there, and you can literally copy it, like copy that and paste that into this big gray SSH field that you had in GitHub. Right, so that's new SSH key. Then in the title field, add a descriptive label like personal laptop, or in this case, Jupyter Hub. And then this is an authentication key. And then in the key field, you paste your public key, which you can get by doing this cat. I'll copy this into Slack. Do that, then you'll have a string here, and that's the string that you paste into the key field, and then click add SSH key, and then you should be configured in there. Okay, let me know when you're done with step 2 in Slack by giving me a thumbs up there. And again, just to clarify, the SSH key is there as a way for you to authenticate against GitHub. That's the reason we're giving GitHub the public part of the key. We're giving the public key, and now whenever our machine tries to talk to GitHub, GitHub will go and check, do you have the right private key that matches this public key that you gave me? And that handshake is the way that GitHub knows that you are who you claim to be and that you're allowed to do operations on your GitHub account using Git on your machine. And that is the reason that I could, for example, do this push. And that's because I already configured so now when I did the push, it added stuff into this repository, and that was allowable because I already did this configuration and knew that I am the person working on this machine is the same person as this Rokem user on GitHub. Okay, and I see that many of you have done that next step, and okay. I'll wait just one more second here. So, before I move on, I'll just say there are different ways of thinking about working with Git. Git is a system for version control, and you can think of 3 different levels of working with Git. One is that you work by yourself, you have a repository on your computer, and you track all the work that you're doing by yourself on the computer. And it gives you a log. You can think of this log as kind of like a record of everything that you did. And it allows you to maybe like go back and look at when you made what changes, and it allows you to recover some changes that you made. If you made some change and you want to revert that change, you can go and see the state of the repository at different points in time. And so it allows you to keep track of all the changes that you did. And that's really good. And that's kind of the first level, is like by myself on my machine. The second level of using Git is when I use Git as also like a backup system. So that's when I have a remote. For example, I have GitHub as a remote, and I make commits on my local machine, and then I push those commits to GitHub. And now I have a backup of that. And this backup can be, in this case, this is a public repository, but it can also be a private repository. And so I can keep, you can think of this as a remote offsite recovery. Like if my laptop, something happens to my laptop, or I don't know, something happens to the computer that the Jupyter Hub is on, I have another backup in GitHub that has all the history of the project, and I can always recover. So that's the second level. The third level of using Git is when you start working with other people in collaboration. And they can also pull your code and make changes to the code, and you work together. Different people make changes to the code at different times. And that's kind of where we're headed next here, is where you can make changes to the code too, and we all work together with this one central repository. So the first thing that, in order to be able to do that, the first thing that I'm going to ask you to do is to pull the code that I have created here onto your machine. So let me think about this for a second. Yeah, let's do that. So if you go here and you copy this URL, if you go to this page where I've put my repository, you'll see a green button here. It says code. And depending on how you have GitHub configured, it might have the HTTPS version, the SSH version. What I want you to use is this SSH version. So I'd like you to copy that, and I'd like you to go somewhere on your machine that you want to put the code. For example, you can go to your home directory and you can issue there git clone, and then you will paste that URL there. So git clone git@github.com /arokem/geometry.git. Somewhere in your Jupyter Hub, you should issue this so that you should get the code into your machine as well. Okay, and then maybe once you've done that, give me a thumbs up in Slack on that. Or if you run into trouble, just let me know about that too. Yes. So Joe posted this error. It's not actually an error. This is the first time that you communicate with GitHub. Your machine is asking, "Oh, are you sure that you want to talk to this machine?" And what you need to do there is to type yes and hit enter. And if you do that, then it will know, oh, that's an okay thing to do. Yeah, thanks for pointing that. I forgot that this would happen every time. This is so in just to give you another kind of sense, in your home directory, there's this SSH directory, and it contains your keys. It also contains a file called known hosts. Known hosts is a file that contains all the hosts that you have communications with. And once you ran that, it will add GitHub into that file. Okay. So now, assuming you managed to clone that, you should have a copy of the code somewhere on your machine. And now, don't change anything to the code quite yet, but let me do one more thing here, which is, you remember that there was, when I typed get status, it said, oh, you have all these other files in here. And these are files that I actually want to ignore. This here, .ipyb checkpoints, that's backups and checkpoints of Jupyter notebooks. And this PyCache here is a folder that gets generated with bytecode when you import the code. And build is a folder that gets generated when you install the library. And this is also true for this one as well. So I'd like to tell Git to ignore that. So what I'm going to do is I'm going to touch a file called gitignore. And I'm going to copy all of this here, all these files. And I'm going to edit this gitignore file. And I'm going to put all these names in here. And you won't need to repeat this because in just a second here, I will give you these changes through GitHub. So sorry, I had some spaces, so I'm deleting all the spaces at the beginning. These need to be at the gitignore is a special file that you can have in your Git repository that tells Git, oh, there are these patterns, certain patterns that we can safely ignore. We don't need to track those. So I save that, and then I exit, and now when I type git status, you'll see that all these files that I told it to ignore are now no longer recognized at all, right? They don't appear in the untracked files, but there is this one new file, .gitignore, that I added, and that file is now present in the repository. So I'm going to git add gitignore, the file that I added, this special ignore file. And then I'm going to do git status, and that will show me that there's a new file to be committed. So this is now in the state, this file is now in the staging area. And then I'm going to do git commit and add gitignore. Save and exit. Okay. So now when I do git log, you'll see that it has at the top this gitignore. So now what I will do is I will git push origin main. Git push has many words in it. Git, the way this works is git is the name of the application, push is a subcommand, and this subcommand takes two arguments: the name of the remote to which we're pushing and the name of the branch to which we're pushing. And when I do that, it pushes up to GitHub such that now when I refresh here, it adds a gitignore. Sorry, it added that commit. So now my commit log includes this most recent commit, and the file is in here. So now you can locally issue inside, if you're inside of the geometry repository, you can issue git pull origin main, and that should pull these changes to your local machine. So again, I'll put that in the Slack, and then you can tell me when you got those changes. Okay. Give me a thumbs up in Slack when you have the gitignore file on your machine. And so now we're collaborating, but it's a pretty one-sided collaboration. I pushed, you pulled. And we can keep doing that. I can keep pushing, you can keep pulling. But in order to actually make us collaborators, I need to let you also push into the repository. And you can see that if you try to push into the repository now, if you make some change to a file and you push, then you won't be able to push. And that's because you don't have the permissions to push yet. But let's actually start doing that. So what I'm going to ask you to do now is to do one cycle of changes on your local repository. So if you navigate to where your repository is, in my case, it's inside of source and geometry, and you go to the README file, go and make some edit to the README file. Like I'm going and I will go and make some change here, for example. I'm making some change to the file. So if you make a change to the file, now you can do git status, and it will show you the change, that there is some modification to this file. Go ahead and do that on your end as well. Go and make a change to the README. You don't have to make the same change that I did. You don't have to make the change in the same place. Go and make some change to the file. And then if you do git status, you'll see that there's some change. You'll have to make a change and then save the file. And if you type git diff, it will show you where the differences are, right? So I can see that it marks, when you do git diff, it shows you this kind of interface of like what deletions happen. In this case, there's a deletion of some code. And the reason this is a deletion is because we changed this. We added some new lines here. So it has some added code to this line, and then it shows us that there's this new line in the code. So this is the way that we know that there's a change. Git status tells us which file has been modified. Git diff tells us what the changes are, and we can make a commit of that. Sorry, we need to do git add first. Git add. Oh. Joe, you need to be inside of the Git repository to do git pull origin main. So in your case, you might need to do something like cd geometry, which will bring you into the geometry folder, and then you can do git pull origin main. When you clone the repository, it doesn't place you inside of the repository. So do git clone the repository name and then cd into the repository, cd geometry, and now you're inside of the repository. Okay, so in my case, I need to do git add readme .md and git commit added more information to the readme. So I have more information, and I'm actually not going to push that quite yet. And that's because what I want to do next is I want to designate one of you as a collaborator who can push to the repository. So I made a change to the README file, and I want somebody else to also make a change to the README file, and then I'll give them permissions to push to my repository. So can I get a volunteer who would like to be my collaborator? Anyone willing to be a collaborator? Try this out. Type into Slack that you want to be, raise your hand, do something. Thank you, Caitlin. You are it. Okay. Thanks a lot. What is your GitHub username? Type it in Slack so I can. All right, great. Thank you. All right. What I'm going to do is I'm going to add you as a collaborator to this repository. And that's done in the repository. So we created this repository in GitHub. Then we pushed some code into it. And now we're saying, hey, I want to work with somebody else on this. So what I'm going to do is I'm going to go to the settings, and I'm going to go to the collaborators tab in here, and I'm going to add you as a collaborator. I'm doing that by putting your username in here, and that's you. And then I'm adding you in here. And here now you are you should have received, there's a pending invite. The idea is GitHub wants to make sure that you want to be a collaborator on this repository. So it sent you an email saying, hey, Ariel invited you to collaborate on this code together with him. Are you willing to be a collaborator? So go to your email and accept my invite. Let me know when you've accepted. Okay, great. So now you should be a collaborator. And what that means is that you should be able to do, make a commit. Did you make a change to the README file? Yep. Okay, great. And did you make a commit with that change? Okay, great. You're making a commit. Yes, please go ahead and push. So you make a commit and then you do git push origin main. And that should, so it's the kind of like the opposite of git pull origin main is git push origin main, right? So you can push, you can pull code and you can push code. Okay, so the change was pushed. So let's see what happened here. Okay. Ha. So now I can go and I can see the change that Caitlin introduced, or don't, up to you. Beautiful. Okay, great. So now we're in full collaboration mode. I can, in fact, go and git pull origin main. And that should then, okay. The first time that I do this, it will say, hey, there are different ways that because you have a branch with one history. The idea is my main branch has this history that I showed you up here. And the main branch up here has a different history because it contains this new commit by from Caitlin's work. So we have divergent histories. And Git wants to know, how am I going to reconcile divergent histories? And what I'm going to say to it is git config dash dash global pull.ff only. And that will tell it that only fast forward changes are allowed. Fast forward changes are changes that are not destructive. I believe that's what I'm supposed to do here. Okay, so now let's try git pull origin main. Oh, you can't fast forward. Okay, I'm wrong. A git config. Let's do pull.rebase false. Okay, so on your machine also, go ahead and configure this configuration so that when you do a pull next, it will, no, it's having trouble with that. Let's try true. Let's see. It didn't add that. Sorry, let me remind myself how this works. Sorry, I'm gonna do this surprises me, so I'm gonna do the too obvious thing and Google this. Let's try this one. Oh, here it is. Okay. Yeah, okay. So what it did is it added Caitlin's commit in here, and then it added my commit on top of that. We'll do this again here. So I think the configuration you want is this one. I'll try it with the false one. Caitlin, can you make another change and another commit and another push? Or does somebody else want to practice that actually? Does somebody else want to be my collaborator? I'll add more people here. We'll get a lot of complication going. Can I get one more collaborator? Send me your GitHub username and I'll add you. I'm not getting much traction here. Ah, thank you. All right, one more person. All right, so now you should get an email that invites you to collaborate as well. And once you accept that, you should be able to push your changes as well. Let me know when you've had a chance to try that. Are you able to push? Let's see. Ah, can I push a random thing? Yes, the answer is yes. Okay, so you added a different file. That's good. I like that. And pushed that. And that added another commit. So you can see now the history. So we're all collaborating together. And now I should be able to do git pull origin main. Will give me all these mysterious. Still doesn't like that for some reason. If I do git merge, I'll do that. Oh. This is like a new version of Git that does these things that I am not entirely familiar with. Sorry about that. Guess there is a way out of this, which is to do the git rebase every time. So rebase is a way to sort of add commits on top of other people's commits. And this will only happen when I have a commit here that is not yet in the repository. So if I do git rebase origin main, and then it rebases, and then git pull origin main, it will say that it's up to date, and then it has all the commits, including my most recent commit. Okay. So it's a bit of a two-step thing. Yeah, exactly. It's I have a commit that's not only staged, but also it's committed. I have this commit that's committed in my history that doesn't exist in the remote yet. So that's why I have to make that rebase happen. So I'll show you again. The steps are git pull origin main, and then it has that complaint. So then I do git rebase origin slash main, and then it kind of like plays my commit on top of the history from the remote. And now I can do git push origin main, and that should push the commit in here. And now you can see there's more information. And now all of our commits are now layered like that. In fact, let me ask Caitlin and also who's the other collaborator? Muye, to both issue a git pull origin main on your side and see whether you get each other's commits cleanly into your repository. Okay, great. Now we're going to do something a little bit wonky. I'm going to ask Caitlin to make a change. Both Caitlin and I are going to make a change to exactly the same lines of code. So let me close this file. Often the Jupyter Hub will keep keep versions of the file that are not up to date. But now if I open this README file here, I have the change. Do you remember Caitlin's change? I have it right here. So what I'm going to do is, Caitlin, I'm going to ask you to make a change to exactly the same line that I am making a change to, but make a different change than the change that I'm making. So I'm going to write I would though, and I'd like you to make a change to exactly the same line that I'm making a change so that we can have a conflict between my change and your change. And then I'm going to make a commit git add readme and git commit. And I'm going to wait for you to push your change there on top of my change. Yes, please do push. So git push origin main. Okay, so now, okay, change to cause problems. Yes, this will cause problems because now when I do git pull origin main, it will let's try this git merge origin main. All right, so when I try to merge your change here by doing git merge origin main, it says, look, there's a merge conflict. So I tried to pull your change here. It pulled down your change. It says there's diverging branches. So now you either need to merge or rebase. And I tried to merge that, git merge origin main. And it said, I can't do that because there's a conflict. So that's just a fact. Sometimes Git can do very cleanly, like it did between our previous changes. It can very cleanly merge between like this change here and my change here. But sometimes it'll run into trouble if two people have made changes to exactly the same line. There's really nothing Git can do except to tell you that there's a conflict. And what it does is it adds these conflict markers. So, so this is the change. You can see this is the change that Caitlin introduced, and this is the change that I introduced. And in cases where you have these kind of conflicts, you need to go and you need to resolve the conflict by hand. You need to go and edit the file and say, okay, this is the version that we will keep. So you go and you edit where the conflict markers appear, and you then save that. And now if you get status, it will tell you that you have unmerged paths, meaning something has changed in this file in some way that requires the conflict to be resolved. Once you have resolved the conflict by changing the file itself, then you can do git add readme.md and then git commit. And then when it opens this commit, it will say, oh, I merged some remote tracking branch, this origin main remote tracking branch in here. So now, and it said there were conflicts. It kind of records all these things that happened. And now I can do git push origin main. And now the version that will be up here will be this merged version. So if you look at README, we'll see that it contains the information that Caitlin wanted this file to contain, not the information that I put in there. But if we look at the commit history, we'll see that my commit with this change still is in here. Right? So what Git did here is it allowed us to resolve the conflict between the changes that Caitlin did and the changes that I made. And it kept both versions in the history along the way. So this allows us then to collaborate even in the same lines of code. Different people can make changes at the same time and still be able to resolve these conflicts locally by editing the files. Okay, let me stop here and see what questions you have at this point. Let me add one more layer of complexity here. to this, which is that we'd like to actually avoid these kind of situations where different people are working on in the same place, and different people are making changes, and merge conflicts happen and of these kinds. And the way to avoid that is to never work on the main branch. And so now I'm going to introduce you to the idea of branches. Branches are ways for us to change the code without changing what is happening on the main branch. So you can think of the main branch as being the version of the code, the version of this repository that we keep clean and we never touch. And what we're going to do is we're going to make branches of the code where we can make some additional changes. So the command is git branch. Let me call this git branch add test file. And then in here, I'm going to add this test folder. And then I'm going to, in the test folder, maybe I'm going to add a new file, touch tests. Oh, sorry. I need to first check out the branch. So git branch will tell you that we have, after I've created the branch add test file, git branch will tell you that there's a new branch called add test file, but we actually need to switch over into this branch called add test file by doing git checkout add test file. And now you can see that the green and the star have moved to this other branch. We were on main, and now we're on this add test file branch. Okay, so the changes that we make now will be in the add test file branch. Now I'm going to touch tests, test circle.py. I'm adding a new file where we will create tests for our geometry code. And here I'm going to do git add tests, test circle. For now, I'm going to just add I'm going to just add an empty file, test circle, and git commit adding that, and git. So now if I look at the git log, I can see what I'll see here is that this new commit is here in the history, and it points out, in fact, that it's on this other branch add test file. And the main branch, the branch that we mostly worked on until now, is behind the history. And I can switch. One of the nice things about the branches is that I can switch between them very rapidly. Git checkout main, and if I do that, oops, sorry, I was in the wrong place there. You'll see that in here I don't have a tests file, and then if I do git checkout add test file, it literally, if I refresh here, it literally adds this folder in here. So on one branch, this file does exist, and on the other file, on the other branch, the test file doesn't even exist. And I can push origin add test file to GitHub. And that creates a new branch up here. You'll see there's a little branch selector here. This little branch selector, when I refresh, it has two branches. I can switch over to the add test file, and you can see when I do that, I have the test circle file, this empty file that I added in this new branch. But if I switch back to main, that folder and that file don't exist. And the history has diverged. This has 10 commits that end in this merge remote tracking. And this other branch adds a test file. So this allows me to do new experiments on this branch that don't affect the work that is being done on main. I can add new features here. I can add new ideas into this other branch that are not going to affect what is happening on the main branch. This is good because let's say that I'm working with other people on this code, and I want them to be able to pull the most recent version of the code that is tried, true, and tested. That's what's on main. And if I do some experiments, I make some changes, I can make those changes in different branches, in different versions of the code. And when I check out the branch locally, it changes the file system. So git checkout main will take me to a different version of this code that doesn't have the tests file. And again, git checkout add test file will add back that test file. Two different versions of the file system. Now, how do I incorporate this branch into my work? I can do that by creating what's called a pull request. You can see that GitHub has noticed that I pushed a different branch, and it creates this new dialog, and it lets me compare and make a pull request. What it does is it opens this dialog, and that then allows me to say what this is for. I can write a little message in here. When I do that, this will send an email to all the collaborators on the repository. So in this case, Caitlin and Maria should have received an email. And because they're collaborators, they can look at this code. They can say, oh, okay, you've added a test file, fine. We can have a conversation. They can write comments in here. They could say, I like this, but what about some content? And that then gets into this interface. The nice thing about this is that we've created a separate version of the code that we're asking to get merged into the main branch, and we can have a discussion about this before it gets merged into the main branch. So, for example, I can add some tests in here. For example, def from geometry dot circle import calc area or calculate area. And then I might have a function def test calculate area, which has, for example, assert calculate area of 1 equal or right, so this is a test for the code. We saw a little bit of testing from Russ earlier today. Also, he mentioned that this is a good idea if we're going to do AI coding to write tests first. So here I'm writing a test that calculate area of 1 is close to 3.14, which it should be. It should be close to pi. So then, happily having done that on my add test file, I can make another commit, git add tests, test circle, and make a commit here. Adds test function. And then if I push origin add test file, notice again, this is the way this works is git push, the remote is origin, and the branch is add test file. This then goes into the same pull requests that I had before. So you can see the commit gets added into the pull request. Right, so now when we go to this files changed, you can see that there is a change. This diff is going to be the addition of code that will get incorporated into our code when this pull request is merged. Okay, now let's say that we're all happy with this change. Then one of the collaborators can go and merge this pull request by hitting this green button. So maybe Caitlin, maybe you can go here into this dialog. So going to the repository, into pull requests, into the first pull request, and then hit the merge pull request button. Once you're happy, you hit the merge pull request button. All right. So it was successfully merged, and so you can see that this was merged and closed, and that means that the pull request is now closed. This dialog doesn't show an open pull request anymore. It does show a closed pull request. We can always go back and look at the pull request here in this dialog, but it's now closed. And in fact, now the most recent commits in the main branch are my addition of the test file, my addition of the test function, and this merge. And now we can check out the main branch, and then git pull origin main will now pull in this fast forward, pull in this test so that now the main branch is up to date with the with this full history, right? With the two commits that I made on the branch and this merged pull request. Okay, what questions do you have at this point? Okay, if no questions, what if two branches conflict badly? Right, so this in some sense solves the problem of having lots of conflicts happening on the main branch. You don't want any conflicts to happen on the main branch. If the branch that you have conflicts with the main branch, you will need to resolve that with the main branch. And the way that you do that is by, let me demonstrate this real quick here. Git branch, new branch, git checkout, new. I'm going to ask, Muya, can you actually make a change to the README? Let's make, the both of us make changes in the same place. So I'm going to write here something, and you write something on the same line on your end so that we get a conflict. Whoops, I closed too many things here. Oh, I know how I can get that back. Okay. So I'll go here, git status, git diff, git commit, git add readme, and you on your end do the same thing. You do that. You can do that on the main branch. So I'm going to do that, and I'm going to make another pull request here. But let's not merge that pull request quite yet. So I'm creating a new pull request. And then I'll wait for you to push some change to the main branch. In the same line. Let me know when you've done that. Sorry, it should be on this line. All right, great. Thank you. Okay. Okay, so now we have added some lines here. So now what will happen is if I close this and I go here and I go get check out. Oops, sorry. What am I doing? Check out full. Yes, to your question, Agatha. Yeah, they can see people that are not collaborators. Everyone can see what's going on by looking over here at this repository. Now, if we look at the pull request, I think what we'll see is that when it checks, it'll tell us this branch has conflicts that must be resolved. And in fact, you can go and you can resolve the conflicts on the web here. GitHub has an interface like this that lets you can do the resolution right here in GitHub. But let's not do that. Let's show you what happens locally. So now I have branch. What I see now is that there's a pull request. The pull request is conflicted, and the way to solve that is in the new branch to do git merge main. So we always merge from main into branches and not the other way around. And what it will say is there's a conflict right here. So when I try to merge those two branches, it shows me the conflict. And then I can say, well, I still think we need to let's maybe combine these two versions of the code, so we have something new that combines both the changes that I made and the changes that Maria made. And then I save that. And on my branch, I can say git status, both modified, git add, readme. And then it says again, I merged the branch main into the new branch. And now I'm git push origin new branch. And now, if we go to the pull requests, now when it checks for its ability to, merge, now there are no conflicts with the base branch. And the content that is in here is both the content from main that Muya made and the change that I made. So this is really the way, kind of like to summarize everything, since we're also at time, to summarize it, the way that we work with pull requests is we make a branch, we push to the branch, we make a pull request. If other changes happened on main in the meanwhile, we merge those changes into our branch. We resolve the conflicts on the branch. And that way main is never in conflict. And that's because we always make our changes and we always resolve the conflicts on the branch before it gets merged into main. And we can keep doing this here. The branch can keep on going for a while before it gets merged. Okay, so this is really kind of the full Monty here is or the full thing is you make changes on a branch, you push that branch, you make a pull request, and then you keep, as you're working on the branch, you keep merging the changes that happen on main into your branch. You resolve any conflicts, and you keep pushing into the branch until it's ready to be incorporated into main. Once it's incorporated into main, everybody who is a collaborator on the repository can go, let's say that I now go ahead and merge this pull request, confirm. Usually this should be done by some other collaborator after they've reviewed the code. Now if I do git pull, git checkout main, git pull origin main, and now it's fast forwarding, and now the main branch has the new pull request added as well. So everything gets kind of folded into the main branch. We make branches, we make pull requests from those branches, and then everything gets folded into the main branch eventually. And so on and so forth. We keep pulling from origin main, keep making branches, pushing those to new branches, making pull requests, and then merging back into main and pulling from main and so on and so on and so on. And that's how we can keep working on that. Now, there are more complications, of course, to how to use GitHub, and maybe we'll get to those later. For example, it's possible to for a person to make a pull request on the repository, even if they're not a collaborator on that repository. And that's done by making what's called a fork of the repository. It's not something that I have time to show to you right now, but you'll notice that there's this button right here. And so if somebody wants to become a collaborator without me knowing them, they can make a fork of the repository, make their changes on that fork, and then ask to merge from that fork of the repository onto this repository. And that's a pattern that's common when in large collaborations where people don't really know each other. I won't show you this in detail now, but we can look at it later also in this week or next together if people are interested. Okay, what questions do you have about all that? Okay, hopefully you'll get to practice a lot of this together this week and also next. I find this to be really, really useful. Git and GitHub, once you get started with it, it's a really good way to collaborate with others. I do a ton of my work, papers, code, analyses on Git and GitHub. I just find that once you get into this workflow, it really accelerates your ability to work with others, to do really complicated things with other people. So it's really, really worthwhile and valuable. Okay, if no more questions, I believe we're at time now, and we have another lecture coming in about 30 minutes. So let's stop here and then resume in 30 minutes.